This screencast is on atoms, so a review of what we did in our last screencast with protons, neutrons, and electrons, isotopes, and ions. So how do we change those numbers when we're dealing with these other particles? Let's start with our review. Remember that atoms of different elements have different numbers of protons, while atoms of the same element all have the same number of protons. We determine our number of protons with the atomic number. So in our example here, oxygen has an atomic number of 8. That tells me that there are 8 protons and 8 electrons in this atom. To find my number of neutrons, I round my atomic mass to 16, and I subtract my atomic number of 8 to get a total of 8 neutrons in the atom. So how are isotopes different? Isotopes are atoms of the same element, that have different masses. So it's going to have the same number of protons and the same number of electrons, but it will have a different number of neutrons because that mass is different. Most of the elements on the periodic table consist of mixtures of isotopes. Your mass number, if you recall, is the total number of protons and neutrons that make up the nucleus of the isotope. So we round the mass from the periodic table to the nearest whole number to determine the number of neutrons. The periodic table lists a mass that is an average of all isotopes that occur, and this explains why the mass on the periodic table is a decimal number. In a future screencast, we'll talk about how we calculate the average atomic mass for an element. For now, let's look at an example of an isotope of oxygen. Here on the left, we have oxygen 16, which tells me my oxygen has a mass of 16. My atomic number for oxygen is 8, so I have 8 protons and 8 electrons. To find my number of neutrons, I take my mass number of 16 and I subtract my number of protons, 8, and I get a total of 8 neutrons in the atom. Oxygen 18, on the other hand, has a mass of 18. Notice I still have 8 protons and I still have 8 electrons because my atomic number for oxygen has not changed. It is still 8. To find the number of neutrons, I take my mass number of 18, I subtract my number of protons, or 8, and I get a total of 10 neutrons. Notice that the only difference between these two models is the number of neutrons. That's because in an isotope, your number of protons and electrons stays the same, but your number of neutrons changes because the mass number changed. So how do we designate isotopes? We have 2 ways of writing or notifying people that we're dealing with an isotope. One is called hyphen notation and the other is nuclear symbol. In hyphen notation, you write the name or the symbol for the element followed by the mass for that isotope. In nuclear notation, you write the mass as a superscript and the atomic number as a subscript, followed by the symbol. So for uranium, we have 92 protons and 92 electrons because that is the atomic number for uranium. But the number 235 tells us that the mass is a little different. So if we wanted to calculate the number of neutrons, we would take the mass of the isotope, which is 235. We subtract the number of protons, or 92, and we get a total of 143 neutrons. Let's try a sample problem. How many protons, electrons, and neutrons are there in an atom of chlorine-37? Well, the first thing I want to ask myself is, chlorine has how many protons? If I look at the atomic number from the periodic table for chlorine, I see that the atomic number is 17, and that tells me that I have 17 protons. I know that my number of protons is equal to my number of electrons, so this means that my number of electrons must also be 17. Because my isotope is chlorine-37, that means that 37 is the sum of my protons and my neutrons. So to find my number of neutrons, I take my mass of 37, I subtract the number of protons, which is 17, and I get a total of 20 neutrons. Ions, on the other hand, are an atom that has a charge. So we're no longer dealing with a neutral atom, we're dealing with an ion, or an atom that carries a charge. The atomic number tells you the element and the number of protons, but when you gain or lose electrons, you form an ion. Ions are designated with a superscript charge. So for example, we can have sulfur, that's designated S-2 or S2-, and we can have aluminum that has a charge of +3 or 3+. It does not matter which way you write the symbol for the ion, but please note you must have the plus or minus to indicate whether it's a positive or a negative charge, and you must also include the number 3 or 2 because you want to designate the magnitude of the charge. When we look at S minus 2, the minus 2 indicates that there are 2 more electrons than protons. And in the aluminum with the plus 3 charge, the plus 3 indicates that there are 3 less electrons than protons. I know this can be a little confusing, but we want to remember that electrons are negative charges. So if we add more negative charge to the atom, then overall the atom will have a negative charge. And if we take negative charges away from the atom, then the atom will have a positive charge. Again, ions are atoms with a charge, and they go by 2 different names. If the ion has a positive charge, it's called a cation, and if an ion has a negative charge, it's called an anion. Now, the way I remember the cation is I think back to the old Tom and Jerry movies. When the cat would get hit over the head with a baseball bat or a club or something, he would get stars in his eyes. And eventually those stars would turn into little X's. Well, if I turn the X on the side, it looks like a plus sign. So a positive charge is a cation. Remember that a cation means that you've lost electrons, and an anion means that you've gained electrons. Gained or lost electrons form ions. And again, electrons have negative charges. So for my example, if I'm looking at Fe with a plus 2 charge, this is a cation, and the plus 2 tells me that I have lost 2 electrons. Nitrogen with a minus 3 charge tells me I'm dealing with an anion, and the minus 3 tells me that it's an atom that has gained 3 electrons. Try the following practice problems. Identify the number of subatomic particles in the isotopes carbon-14, nitrogen-15, and hydrogen-2. Identify the number of subatomic particles in the ions oxide, potassium, and phosphide. Write the answers to these practice problems at the end of your notes and show them to Mrs. Benke.